So in this video, we're going to talk a little more about similar figures, in particular similar triangles, and how to prove that two triangles are similar. Just as a reminder, with similar figures, you use the little squiggle shape here. That means they're similar, meaning they're the same shape, but possibly different sizes. They could be congruent. Congruent figures are similar, but usually they're different sizes. When you have similar figures, like these two triangles here, all the corresponding sides have the same ratio. So like 7 to 14, 10 to 20, 6 to 12, it's all the same ratio. All the corresponding angles are congruent. So these angles are congruent, the same. These angles are the same, these angles are the same. Basically this happens from any sort of transformation, particularly dilations. So think about what would be the minimum amount of information I need to prove two triangles are similar. So these look similar, but how do I know? Is it enough to just know that like this is a 6 and this is a 12? Like what could these other sides be? What might these other angles be? Do you think that these two are proportional as well? If this is 6 and 12 and this is 7 and 14, is that enough to know that, okay, now they're similar? Do I have to know the third side? Or if I knew that like these two angles were congruent, is that enough to know that they're similar? So feel free to play around with that a little bit more, but the conclusion is there are actually 3 ways that I could prove triangles are similar. Any of these ways will work, but you have to have one of them. So the first one we call SSS, that stands for side, side, side. So basically with this one, as long as you have all 3 sides of the triangle that are proportional to each other, then that will prove that they're similar. I'll show you some examples in a second. The second way you can prove they are similar is if you have 2 angles that are congruent. So a pair of angles and another pair of angles that are congruent. That will prove that they're similar. And that's actually all you need. Like here, if I had these 2 angles are congruent and these 2 angles are congruent, that automatically tells me that the third is congruent because they have to add up to 180 basically. So that tells me that the third angles are congruent, and that's enough to say that they're similar triangles. Not necessarily congruent triangles though, because just because the angles are the same doesn't mean the sides are the same. And the third way is if you have 2 proportional sides in the triangle and an angle in the middle, that will also prove that they're similar. So we call that side angle side, or SAS, but basically I'll show you an example. Just keep in mind when I talk about the sides here, the sides only need to be proportional, as in like same ratio, not congruent. The angles though do need to be congruent. So here's some examples. This is an example of 2 triangles that are similar by the side, side, side property, or SSS, because each pair of corresponding sides has the same ratio. And how do I know like which side goes with which side? Well, if the 2 is the smallest one over here, then that would need to go with the smallest side over here, which is 3. So 2 goes with 3. Is that the same ratio as this medium side, 4, to this medium side, 6? And is that the same ratio as this long side to this long side, 6 to 9? Yeah, each of those are just 2/3. All those ratios are equal to each other. We could say that all the sides are proportional because these ratios work out. So if I wanted to write that these 2 triangles are in fact similar to each other, I would say triangle ABC is similar to, remember this symbol means is similar to. So ABC is similar to triangle, and I want to make sure I do this right. I can't just put DEF and hope that works out. If I put ABC, that order matters over here. So like AB was the short side of this triangle. And so I need to line that up with the short side of this triangle, which was actually DE. And then AB went from like the long end to the medium end. And so I need to go from this long end to the medium leg or side. So I'll go D, E, and then F. Like BC was the medium side here, and so make sure that EF is this one's medium side, EF. And AC was the long side, and so DF should be this one's long side, which makes sense. So they're similar. And I proved that by the property, by the side property. So if you ever need like justification for like, why is this true? It's because of side. I proved that all of the sides were proportional. Here's an example of angle. So in this particular case, C is congruent to E, B is congruent to D, and so that's two pairs of congruent angles, like two corresponding pairs of angles that are congruent. And so that's it. I know that these are similar by the angle postulate. If you hear the word postulate, it just means like a theorem or a property or a rule. That's what we call these sometimes. So the statement would be triangle. I'm going to go with ABC is similar to triangle. A was the one with no mark, so that should be F. B was the one with one mark, so that's D. And E was the one with two marks, same as C. So FDE, the way I've got it written here. It's okay if you switch up the order, but you got to switch it on both. Like if I had said BCA, I would need to go DEF. So is triangle ABC similar to DEF? The answer in that case is no, because AB does not match DE. AB was blank angle to one mark, and DE was one mark. Oh, sorry, I lied to you. This is accurate. A was the no mark, and F was the no mark. Oh, no, this doesn't work out. Because A should be nothing here, and this statement has it matching up with D, which should be a one mark. And so this is not true because A and D don't go together, and B and E don't go together because B was 1 and E was 2. So this is not true. All right, the last one, and this is the final way that you can prove that two triangles are similar, is if you have two pairs of corresponding sides where they're proportional. They don't have to be congruent, just proportional. And the angle in between them is congruent. So for example, do you see how on this one we've got 4 to 8, or if you like doing the bigger one on top, that's fine, 8 to 4. And we've got 6 to 3. Are those the same ratio? Yeah, they're both just 2. So this is one pair of corresponding sides. This is another pair of corresponding sides. So that's like the S and the S. And now we need to check that the angle in between those two sides is congruent. And we have that. This arc and this arc indicate that these two are congruent. We could say angle B is congruent to angle E. So that means these triangles are similar by the SAS property. And so I could say a triangle, I'm just going to go with ABC again. So ABC is similar to triangle FED. Making sure I go in order there. Just to be clear, this does not count if the angle is like over here. The angle has to be in between the two sides. See how this angle is in between the two sides? It doesn't count if it were like the angle over here and not this one. that would be like an angle and then a side and a side. That doesn't count. It's got to be the angle in the middle. So let's go through a few examples. So are these triangles similar, and prove your answer. So a lot of what you're going to see in geometry is not just like finding an answer, but actually having to justify it. And as you get into more advanced upper level math, you're going to do a lot more proving than you are actually solving. It takes a lot more logic and maybe writing out your thinking than just like computing some things, because we don't really need calculators, we need people who can think logically. And actually, this is very similar to like proving something as a lawyer in a courtroom. When people apply to law school, one of the most common accepted like undergraduate majors is a math major, because they know that math majors are good at thinking logically and proving things, just by the way. Okay, so are these similar? We have 3 ways, so why don't we test those 3 ways? We can either do side, 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 we can do angle, angle, or we could do side, angle, side. It's got to be one of the 3. All that I'm given here are sides. They didn't tell me anything about the angles, so it's not going to be either of these because those have to do with angles. So if they're similar, it's going to have to be because the sides are proportional. So I'm going to match up this small side to this small side, so 33 to 15. I'll match up this medium and this medium, 66 to 30. And I'll match up the big to the big, 77 to 35. Do those equal each other? You may need to use your calculator a bit. 33 divided by 15 is 2.2. Or you could just divide it by 3 and that would be 11/5. This is also 11/5 if you divide it by 6. And if you divide this by 7, it's also 11/5 or 2.2. So they do actually all equal each other. Like, check, this is a side and another pair of sides and another pair of sides. Side, side, side. So the answer is yes, they are similar, and my proof is literally this. This work right here tells me I've got a pair of sides, a pair of sides, a pair of sides, and so I can say by side, 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 I know that triangle BCD is similar to triangle, I did the medium one first, so GFE. This is my proof. If I'm going to prove it using the side, side, side postulate, I'm going to have to list out all 3 of the sides. You don't really need this part, but this right here is my proof of using the side, side, side theorem. So kind of you just have to show your work a little bit to prove it. Let's try another one. On this one, it gives me 45 is the smallest one here, and that goes with 63. And 50 to 70 kind of goes together. Are those the same ratio? If you divide it, 45 divided by 63 is 7.1-ish, and 50 divided by 70 is also 7.1-ish. It's, if you simplify the fraction, it's 5/7. Sorry, 0.71, not 7.1. So this shows that I have 1 pair of corresponding sides, 2 pairs of corresponding sides, but I don't have 3. So it's not side, side, side. And I'm not going to be able to find this side because this isn't a right triangle, so I can't use Pythagorean theorem to find that side. So it seems like I might be stuck. I can't do side, side, side. So maybe I could do side, angle, side, or angle, angle. Do I know anything about the angles of this triangle? It seems like no, because nothing's given, but I actually do. If you remember from back in the day, anytime you have angles that are across from each other, like this, we refer to those as vertical angles because they're like vertical from each other, and they are always congruent. So anytime you see vertical angles like this, or even like this, these two are also vertical angles, they're congruent. That is the case here. I have lines that cross, and these are vertical angles. And so I know for a fact that they're congruent. So I'm going to write that as part of my proof. So angle FSE is congruent to, remember this means congruent, it's congruent to angle, if I started with F here, I'm going to need to start with U and go down the long side first. So UST. And the reason I know that those angles are congruent is because they're vertical angles. So I'm going to write that. They're vertical angles. That's like the reason. I could put it in parentheses, I could put like an arrow to it, just write it next to it, but it's because they're vertical angles. So now I have side, side, and a pair of angles. And so that is side angle side. So I could say by the side angle side property, I know that these triangles are similar. So triangle FSE is similar to triangle UST. So my proof, if I'm going to use the SAS theorem here, has to include the two sides and the pair of angles, which it does. So that's my proof. Let's try another one. If I want to know if these are similar, how many more do we have here? A few more. Okay, 3 more. If I want to know if these are similar, what I'm going to do is, first of all, I don't know anything about the lengths of the sides of this triangle. I don't know what these lengths are. I'm not going to be able to find them. But I do know that these two angles are the same. They're both 90. So I know that angle CAB is congruent to angle CGF. Because they're both 90 degrees. And if you look at these triangles, they actually overlap. So this big triangle has an angle here that's 53 degrees. And this little triangle has an angle here that's also 53 degrees because it's the same angle. And so I could say, you could say angle C is congruent to angle C, but that doesn't really tell you that it's in both triangles. So just to be a little more specific, angle ACB is the same, like that's the big triangle, that's the same as angle GCF, which is the little triangle. And so this is a pair of angles and another pair of congruent angles, and so that is angle-angle. So by the angle-angle property, I know the triangles are similar. I'm just using this from before because I already knew that was the correct order, so I'm using it again. Okay. On this one, I want to prove if they're similar or not. I'm not given any info on the angles here, just the sides. So I'll need to test and see if these sides are proportional. So does this little one to this little one, so 14 to 55, is that the same as, well, you're probably already noticing, these are both 121. These are not both 34, so probably not the same. So like 32 over 121 is not the same as 34 over 121. And I don't even know if this is the same, but this is all I really need. So at this point, this is the proof. The sides are not proportional, so no. The triangles are not similar, and this is all the proof that I need. If you want to write out in words, the sides are not proportional, that's fine, but this kind of shows it. I don't think that those are equal either. Okay, I think this is our last one. So if I want to see if these are similar, again, on this one, I don't know anything about the side lengths, so it's probably not going to be side, side, side. So it's probably either angle, angle, or side angle side is not going to work either, because again, I don't know the side lengths. So it's going to have to be angle angle. Okay, on first glance, it might seem like these are not going to be the same, but maybe they are. Remember, these two are vertical angles, so I know for a fact that this is the same as this. I don't know exactly what it is, but I know they're the same. You need to remember that a triangle has exactly 180 degrees. Like all the angles in a triangle always total to 180, no matter what kind of triangle it is. And so if this is 60 and this is 34, then basically I need to do 180 minus 60 and then minus 34, and that will tell me how much is left for this third angle. So 180 minus 60 minus 34 is 86. So that is this angle, 86 degrees. Meaning this one is also 86 degrees. I could do this process again, but I don't really need to. Basically, I have one pair of congruent angles, but if this is a 30 and neither of these are a 30, then I'm kind of out of luck. If I wanted to, I could go ahead and find this last missing angle by doing 180, which is this full triangle, minus 30, minus the 86, and you get 64. So this last angle is 64 degrees, which again, neither of these are congruent. I only have one pair of congruent sides, not two. And so, no, these triangles are not similar because I don't have two pairs of congruent angles.